Hey Logan, what's up? Question number 7, solve by completing the square. So this is very similar to question 6. If you don't know how to do this, or if this doesn't make sense, really take a look at question 6 because a lot of the math that's happening happens there. All right, so completing the square, the first step of completing the square is to get rid of the constant if it's not the right square. So rather than trying to figure out if it's the right square or not, let's just get rid of it and then find the right square. Much easier to find the right number than to ask yourself if whether or not the number is the right number, if that makes any sense. Okay, so question A, what we're going to do is we're going to say x to the power of 2 plus 4x. And like I said, we're going to get rid of the constant and we're going to move it to the other side by taking it away. So we take the 5 away from both sides. Next, we're going to find the right c. If you don't know what I'm talking about, take a look at question number 6. Very similar idea. So to get 4, that would be 2 plus 2. So we're going to do this guy over here as 2 times 2. So 2 plus 2 gives us the 4, which means the number that we need to include is 2 times 2. So we're going to say plus 4 there, and we're going to add 4 to the right side as well. That's because there's an equal sign, and that's how equations work. If you want to add a number to the left, you must add it to the right. Next, we're going to factor this thing into its squared binomial. That's going to be x plus 2 to the power of 2. Now, sometimes people ask, why do you want to do that? And the answer is it sets it up for the square root technique. So now we have this square parentheses by itself. We can square root it to eliminate the square. We have to do it to both sides, but don't forget the plus and minus sign. So there is a plus and minus anytime you square root both sides of an equation. The square and the square root cancel each other out, leaving you with x plus 2, making the parentheses obsolete. We have positive, negative. Now, the square root of negative 1 by definition is I. So we write down I. And then we take the 2 away from both sides of the equation, and we have our answer as x equals negative 2 plus and minus I. And those are our two solutions, both of them being complex or imaginary for question A. Moving on to question B. Question B looks a little weird, primarily because it's not in the format as question A. There's no x squared. That's the hint. Since there's no x squared, what we're going to do is we're going to go ahead and multiply. We're going to distribute so that the x squared shows itself. So we have x to the power of 2 minus 8x is equal to 29. Now, at this stage, you have two choices. You can either move the 29 to the left side, but then quickly realize that you have to move it back because it's the wrong number, or you can just leave it there and figure out the right number. And that's what I'm going to do. So we're going to say that 8x is 4 plus 4, which means this guy right here, the perfect number has to be 4 times 4, which is 16. So we're going to add 16 to the left side, but because there's an equal sign, we're going to add 16 to the right side as well. This gives us our binomial squared, which is x minus 4 to the power of 2 is equal to 45. We're going to square root both sides of our equation to get rid of the square. But don't forget the plus and minus sign. And we get x minus 4, but the square and the square root cancel, which means the parentheses are no longer necessary as well. Plus or minus. Now the square root of 45 we can simplify to the square root of 9 and the square root of 5. I choose that over 3 and 15 because 9 is a perfect square. And it makes a lot more sense to simplify perfect squares because we can't simplify non-perfect squares. All right, and we get plus or minus 3 root 5. Last step, get rid of the 4, so we're going to add it to both sides of the equation. And this gives us x equals 4 plus or minus 3 square root 5. And this is our answer for question B. All right, last question, question C for problem 7. This one here, it's pretty close to be, it's actually skipped a step for us. We don't have to move the 1 to the other side, so we're just going to keep it like that. So what we're going to do now is we're going to find the right number. This number here is 7 plus 7, which means the number we want is 7 times 7. In other words, we want to add 49 to both sides, which means we're going to add it to the left and to the right side. This factors to x plus 7 to the power of 2. Negative 1 plus 49 is just 48. At this stage, we're going to square root both sides of our equation to get rid of the square. But don't forget, plus and minus anytime you square root both sides. The square and the square root cancel each other out, which means the parentheses are no longer necessary. We have x plus 7 is equal to plus or minus the square root of 48, which can be simplified. Now, there's lots of different options. We can either do 4 times 12, but if you go a little bit further, you can get something a little bit bigger, 16 times 3. So that's what I'm going to choose to use, 16 and 3 rather than 4 and 12. This gives us x plus 7 is equal to plus or minus 4 square root of 3. We have to solve it by taking the 7 away from both sides of the equation, and the result is our answer. X equals negative 7 plus or minus 4 square root of 3. Just to reiterate, you don't actually need to add the numbers together because you can't. When there's a square root in there, combining it with a non-square rooted number is not possible. And the first problem, question A, you can't combine those because if you have an I, it doesn't combine with non-I's. I'll see you on question 8.